I'm Rayesh Uppal, founder of IDST. We bring you sharp insights and foresight on emerging tech, defense, and security. Let's dive in.
Imagine being on a remote deployment, maybe in the middle of a desert or on a ship at sea, when suddenly a mission-critical component breaks down. In the past, that failure could mean waiting weeks for a replacement part, dealing with broken supply chains, and risking mission delays. But what if instead of waiting, you could simply print that part on the spot on any machine, anywhere in the world, and know with confidence that it would work? That's exactly the bold vision behind DARPA's SURGE program. SURGE, which stands for Sustainment of Use Ready Government Equipment, is taking additive manufacturing, what most of us call 3D printing, to a whole new level. It's not just about making parts quickly. It's about making sure those parts can handle the extreme conditions of military and aerospace missions. Because when lives and billions of dollars of equipment are on the line, there's no room for good enough. Here's the challenge. Traditional manufacturing relies on long, painful qualification processes. Every new part, every machine, every material combination has to go through endless testing before anyone dares to use it in a jet engine, a spacecraft, or a battlefield vehicle. That works fine in a factory, but it's way too slow for situations where failure just isn't an option. SURGE is designed to flip that old model on its head. Instead of waiting months or even years to validate a part, DARPA wants to qualify parts in real time while they're being printed. How? By packing the printing process with sensors that constantly monitor temperature, pressure, and the way the material is laid down, layer by layer. All of that data is fed into advanced digital models that predict how the part will behave once it's put under stress. It's almost like each part gets its own digital health record from the moment it's born. And it doesn't stop there. Additive manufacturing creates unique material structures, different grain patterns, tiny pores, and unusual textures that can completely change how strong or durable a part really is. SURGE is combining that microstructure data with the real-time sensor data to predict how long the part will last before it wears out or fails. Instead of guessing, engineers can know ahead of time how a part will perform and when it might need replacing. Of course, DARPA isn't just relying on computer models and hoping for the best. The SURGE program is running extensive experimental validation, stress testing parts in labs and in real-world conditions, then comparing the results to the predictions. Every time the model is proven right, it gets more accurate. Every time it's wrong, it's refined and improved. Over time, this creates a powerful feedback loop that makes the system smarter, faster, and more reliable. What this means in practice is huge. It could end the slow, costly qualification cycles that have held back 3D printing from being truly mission-critical. Instead of months of testing, you get instant confidence in the parts you print. That could change the way militaries, aerospace companies, and even disaster response teams operate. Imagine having the power to build and certify vital components right where you are, exactly when you need them. And while this program is driven by defense needs, the impact could reach far beyond the battlefield. Think about hospitals in remote areas printing certified medical devices on demand. Think about spacecraft carrying compact 3D printers instead of warehouses of spare parts. Think about any industry where reliability and speed mean everything. DARPA's SURGE program isn't just about better 3D printing, it's about rewriting the rules of manufacturing. A future where high-performance, durable parts can be produced anywhere, on any machine, at any time. A future where supply chains don't break missions. And ultimately, a future where manufacturing has no limits.